people, welcome to my channel. In this video I'm going to tell you about working with variables, like and unlike terms, and many other things. So if you want to know about those things I'm going to tell you now, make sure you stay tuned. Okay, so the first thing I'm going to tell you about is about like and unlike terms. First, terms are a number or a variable described with a letter. So, for example, let me give you an example of terms. A normal rational number or universal set of the number is a term. A letter can be a term, but if it's a variable. For example, 3x can be a term, x can be a term, and so on. Okay, so let me give you an example if we can operate in unlike terms. For example, can you do 3x plus y? You can pause the video and try to do it. Okay, so the short answer for this is we can't operate it. We only can write this as the final answer. For example, if an algebraic expression doesn't have an equal sign, this may be an answer. Okay, so let's go to the like term operation. Like terms can always be in an operation. For example, in an operation, x plus 2x, you can pause the video and try to do this. X plus 2x is 3x, while x is always equal to 1x. Don't forget that this is the same. So if an operation has like terms, for example, in this two of the numbers, for example 2x, this is called the variable. X is the variable, and 2, or the number that comes before x, is the coefficient. The numbers that come before a variable is the coefficient. The coefficients are numbers that are multiplied with the variable if we finally get the value of the variable. For example, if 2y was a question and it said y equals, let's say, 9. All you have to do is, we said that y is 9, so 2, we can substitute y by 9, making it 2 into 9, and this makes it 18. So the conclusion of this thing is that coefficients are always multiplied by the variable if we finally get the answer. So let's summarize this, shall we? So the first summary we're going to be talking about is that terms can be variables or numbers. The main thing is that if they're the same terms, they can be in an operation. For example, terms can be variables or numbers. For example, k, 2, 3y, 9a, 5x, 9 over 5, etc. They are all terms, because if they are in an equation, and then if they're the same term or number kinds, they can be in an operation. So let's go to the second summary. So the second summary is that only like terms can be operated. For example, k plus 2k equals 3k, while k is also denoted as 1k. So 1k plus 2k, making it 1, like this, we can make it like this, 1 plus 2k. And this equals 1 plus 2, 3, 3 times k, 3k. So remember that numbers can be terms too. That's why I've listed it in this example. Numbers can be terms. That's why 4 and 5 can be operated and gives us the final answer 9. So let's go to the third and last summary. So the final summarization, yet not the least, is that unlike terms cannot be operated to give a simpler form. For example, x plus y. X plus y can't give us a simpler form due to its difference in terms. But remember that if we say 2x equals 3y, we can find the value of x or y in terms of the number. For example, if I want to know the value of x, all I have to do is divide it by the coefficients 2. So x gives us 3y over 2. So if we want to know either of the variables' value, there must be an equal sign. But we may find the value of the number in some conditions. So let's go to the next category. So the next thing I'm going to tell you about is working with variables in an equation or an inequality. So this means that we need to know that a number or a variable can be known if there is an equality or inequality sign. For example, let's say x plus 2 equals 20. So we can still know the value of x in this. We can add it or operate it with the opposite of the number we need to get out of the x equation. So this means that x plus 2 minus 2 equals 20 minus 2. But if you don't really want the complexity, you can just move this here, and it loses its positivity, and we cancel it from here, making it x equals 20 minus 2. It's the same to this one, but this one is a little time taking. So x equals 20 minus 2 is 18. So we can say that x equals 18. So 18 plus 2 equals 20. This gives us a true and satisfying number. So let me give you another example. For example, 10x plus 2 equals, let's say, 15. So this may not give you an integer. It may give you a rational number or a decimal. So my point is, by giving you another example, you don't really need to use this. This takes your time, but you just have to get this term, unlike term with x, to the other side, making it past the equal sign, but this makes it an opposite. For example, if this was minus, on the other side it would be plus, and vice versa. So this was plus, right? So this is minus. So 2, and this goes out. It has traveled to the other side, making it 10x equals 15 minus 2 is 13. So we still want to get the x alone. So we can get this as an answer, but we can still simplify it. So I want it as simple as possible. So 10x equals 13. If we want to get 10x to x alone, we must find a way to remove the coefficient. So 10 divided by 10, and we do it on both of the sides, making it inverse. So 10 times x, if we want to create the inverse of this, we must divide it by its coefficient. So x equals 13 over 10, and this equals 1.3. So my point is, you don't really need to use this complex equation. You just need to get the unlike term to the other side. So if we want to know that this equation is accurate, let's do a reversion. We said that x equals 1.3, right? And we must go back to the equation. So 10, let me just clear this one. So as I remember, the question was 10x plus 2 equals 15, right? So we said that x equals 1.3, but I prefer it in the fraction, in the fraction form. So 10 into 13 over 10 plus 2 equals 15. 10 cancels by 10, giving us 13 plus 2 equals 15. So 15 equals 15. So we can say that this equation is right. So let me give you another example in another terms. So the next thing I'm going to tell you about is inequalities. The thing I've taught you before is equations. So inequalities are always come as a x plus b is greater than or less. It can be greater than, less than, greater than, less than or equal to, greater than or equal to c. So we still don't get the exact value of x. We use these signs. So let me give you an example. For example, 3x plus 2 is less than, greater than, let's say 15. So our aim is to get x making it greater than 15. So we use the same formulas in inequalities too. So 3x, we must get this term on the other side of this sign. So it's going to be minus 2. So 15 minus 2 equals 3x. I'm sorry, this is supposed to be greater than. 3x is greater than 13 over 3 over 3. So x must be greater than 13 over 3. There are some exceptional conditions, but before I tell you about that, let me just show you the reversion of this. So all we have to do is write the question again. So it was 3x, but we said that x must be greater than 13 over 3. So for me to know the decimal form and to get the decimal form and find the greater version of 13 over 3, let me just change it to decimals. So 4, 12, 1, 0.3. So 4.3, anything greater than 4.3, let's say 5. So 3 times 5 plus 2 must be greater than 15. So 15 plus 2 is greater than 15. 17 is greater than 15. So we can say that this is correct. And in negative forms, there is an exceptional way of doing this. Let me just show you. So let me just show you the inequalities if a negative. So you can do this by pausing the video. Okay, so if you have done it, let me just show you. Negative 3x. We must get this to the other side. Negative 3x is greater than 5. This must be minus 5 minus 2. So negative 3x is greater than 3. So we must remove the coefficient. And if we divide or multiply by a negative number, sorry, this is less than. If we divide by a negative number, if we divide or multiply by a negative number, this sign will face the other side. So if we make this sign face the other side, finally the answer will be x equals, x is greater than negative 1. So let's check it. We said that x must be greater than negative 1. Let's say a number greater than negative 1, let's say 5. So negative 3 times 5 plus 2 equals, less than 5. So negative 15 plus 2 is less than 5. So negative 15 plus 2 is negative 13. Negative 13 is less than 5. It is, right? So we can say that this is the answer. So guys, thanks for watching. Make sure you like and subscribe if this video was helpful, and make sure to follow our alternate channel about fixing errors on computers. Bye.